Welcome to Next Gen Manufacturing. Have you ever just stopped and wondered how some companies make products that are, well, perfect every single time? I'm talking about your smartphone, your car, these world-class products. They don't just happen by accident. Nope, they are the result of an incredibly rigorous, data-driven system for quality.
So, that's the big question, right? How on earth do they do it? How do you make something perfect and then replicate that perfection a million times over? Well, the secret isn't some magic wand. It's a whole operating system for excellence, a really systematic approach that takes what a customer wants and turns it into a manufacturing reality.
And in this breakdown, we're going to walk through that exact journey together. We'll start with the big picture, the blueprint. Then, we'll see how companies really listen to the customer. After that, how they design a bulletproof product, manufacture it with insane precision, and finally, how they aim for that ultimate goal, Six Sigma quality.
All right, first up, the blueprint itself. Now, I want you to think of this as less of a simple checklist and more like a deeply integrated philosophy. It's really the entire operating system for next-gen manufacturing, where every single stage builds on the one before it.
Everything, and I mean everything, starts right here, with you, the customer. Before a single design is even sketched, the first, most critical step is to deeply understand what you truly want and need. And then, the real trick is translating that everyday language into the language of engineering.
Okay, so let's dive into our first major tool for this. It's called Quality Function Deployment, or QFD. This is just a really powerful method that makes sure the voice of the customer is heard all the way through the entire process. It's about building quality in from the very, very beginning.
At the very heart of QFD is this cool visual tool called the House of Quality, and you build it brick by brick with these 6 steps. You start with what the customer wants, right? Then you figure out how you're going to deliver that, see how those two things relate, and then figure out how much performance you actually need to hit the mark. And this right here, this is the core of that house. It's a really simple but incredibly powerful matrix. See, on one side, you've got the customer needs. We call those the whats. And on the other, you have the technical specs, the hows. This matrix shows you, clear as day, which engineering decisions are going to have the biggest impact on making the customer happy. It's brilliant. So let's see how this all flows into the design phase. We've got a crystal clear idea of what the customer needs. Now the goal is to design a product that isn't just functional, but is totally robust. We want to basically bulletproof the design. Find and eliminate potential failures before a single physical part is ever made. 2 key analyses really drive this stage. First, you've got functional analysis, which just asks a simple question. What jobs does this product absolutely have to do? Then you follow it up with value analysis, which takes that list and asks, okay, what's the smartest, most cost-effective way we can get each of those jobs done without ever sacrificing quality?
Now this next tool is really interesting because it's all about playing defense. It's called AMDEC, which is a mouthful, but it stands for Analysis of Failure Modes, their Effects, and their Criticality. It's basically like conducting a pre-mortem on your product. You get the whole team together and you systematically imagine everything that could possibly go wrong.
And here's a great real-world example from tire manufacturing. For every potential failure, like edge detachment, the team analyzes what would happen and then assigns a criticality score. And that number, that score, tells the engineers exactly where to focus their energy to prevent the most serious problems from ever happening in the first place. The last tool in our design kit is something called Design of Experiments, or DOE. Imagine you're baking a cake, right? How do you find that perfect amount of sugar, flour, and baking time? Well, DOE is a statistical method that helps you find the absolute best combination of all your design variables, and it does it with the fewest, smartest tests possible. It's all about finding that perfect recipe. Okay, so we have an amazing design. It's been engineered for quality, for value, it's solid, but now comes the really hard part. How do you manufacture it perfectly? Not just once, but millions of times, while keeping every single one just as good as the last. The answer is Statistical Process Control, or SPC. This is where we shift from the drawing board to the actual production line. SPC uses real-time data and stats to constantly monitor the manufacturing process. It's all about keeping things stable, predictable, and consistently hitting the target.
Because here's the thing. Without this kind of control, a lot of manufacturing processes are just unpredictable. This chart shows what that looks like. The process is all over the place. It's unstable. It's not centered on the target. And you know what that means? It's churning out a ton of defective parts.
The entire goal of SBC and all the tools that came before it is to tame that chaos. It's to take that wild, unpredictable process and guide it on a journey toward this incredible level of quality that we call Six Sigma.
And look at the result. Just look at it. This is what that exact same process looks like after applying these methods. It's gone from chaos to a single, sharp peak that is perfectly centered on the target value. All that variation has been squeezed out, making the process incredibly stable and capable of producing perfect parts time after time after time. Now, we can actually measure this capability with an index called CPK. It basically quantifies how well a process is centered and how little variation it has. And the gold standard, the number that tells you you're dealing with a truly world-class process, is a CPK of 2.
So, achieving that CPK of 2 means your process is officially operating at a 6 Sigma level. Now, just let that sink in for a second. That means you have less than 3.4 defects for every 1 million products you make. That is a state of near-perfect quality. It is the absolute pinnacle of modern manufacturing.
So what are the big takeaways here? The blueprint for next-gen quality is really a 3-part journey. First, you listen. You use QFD to translate the customer's voice. Second, you design for perfection, using value analysis and failure prevention. And third, you manufacture with precision, using SPC to chase down that Six Sigma goal.
Now that you know the blueprint, I guarantee you're going to start seeing its effects everywhere. Just think about the products you use every single day. Which ones just feel like they were born from this kind of rigorous discipline? And which ones feel like they probably skipped a few steps? The answer tells you everything you need to know about the real power of quality.